piece of wire of length 2 meters is to be cut and bent into a square of side s meters and an isosceles right-angled triangle with equal sides t meters. We want to know what's the length of the third side of the triangle, and we want an equation for the total perimeter stating s in terms of t. So we're going to produce a square of side s and an isosceles right-angled triangle such that the smaller sides are both t. So using Pythagoras' theorem, if we call this one x, so we get x squared is equal to t squared plus t squared. X squared is equal to 2t squared. So x is equal to t root 2. So that's the answer to A1. And then if we look at A2, the total perimeter is going to be 4s, and then we're going to have 2t plus t root 2, and all of that must be equal to 2 because that's how much wire we had. So 4s is going to be 2, take away t into 2 plus root 2, and so s is going to be 2, take away t into 2 plus root 2, all over 4. So we want an expression for the total area in terms of t. So the area would be s squared for the square and a half t squared for the triangle. But we want this totally in terms of t, so we can use this for s. So that's going to be 2 minus t into 2 plus root 2 over 4 all squared plus a half t squared. We now want to find the value of t, which gives the minimum area, and hence state the corresponding value of s. Now this is really hard to differentiate and solve and so on without the calculator. It can be done, and I've done it, but I don't think that's the way the example is intended to be done because it really is quite difficult. So we need to differentiate this, and we're going to use the calculator to help with that. So go into Math 2 here, and I'm just going to replace the t with x while I'm differentiating. So this first bracket is 2. Actually, let's just put a fraction template in there to start with. So it's 2 take away x into 2 plus root 2, and that's all over 4, and we'll square that, and then we need to add to that half of x squared, and that gives us this expression just here. So dA dt is going to be root 2 2t minus 1 plus 7x minus 2 all over 4. Now we want dA dt equals 0, and we want to see what that gives us. So if we go for a solve, and we drag all that lot down here, and we put it equal to 0, and see what that gives us. So I'm in standard mode, so it's given me an exact answer. So that's x equals root 2 plus 2, of course I've used x, but it's actually t, all over 2 root 2 plus 7. Now, if we're doing this as a third, we probably should rationalize the denominator, but I'm not going to bother in this particular situation. And then we want the corresponding value of s. And so, here's our expression for s. We just need to substitute this in. So, fraction template, and we're going to do 2 take away the value of t, which is this, and that needs to be into 2 plus root 2, and all of that over 4, and let's see what that simplifies to. Well, not a lot really. It's going to be negative root 2 plus 2 squared over 2 root 2 plus 7 add 2 over 4. Now we may be able to get the calculator to simplify that. See how successful it is. So that's negative 4 root 2 add 14 over 41. We might be able to do the same sort of thing for this one up here. So where was that? That was here. So let's just copy that. Go down here and transformation, simplify, and paste that there. And that gives us 3 root 2 plus 10 all over 41. Now, it might be worth having these as decimals as well. So let's just change that one to a decimal, 0.2035. So that was that one. And let's just do that one as well, 0.3474. And then we can see if it makes sense back here. So we would have 4 lots of this one, this one, add. Then we've got 2 lots of that one, add, and then we need root 2 lots of t value as well. Let's see. Let's go for decimal. Do that one again. And it does give us 2. So that's a good indication that we got it right.